So the Sheehan STEM team is built on our proof of concept of an ultrasonic sensor for tracking surfaces and moved on to a physical demonstration of ability by developing algorithms that have enabled our Arduino to identify obstacles and flat surfaces while moving the Arduino over terrain that we assembled. In the development process with the Arduino, we ran into a couple big issues. The first was that the Arduino didn't have enough memory to handle the significant amount of data that outputted by the ultrasonic sensor. And we compensated for this with a balance of real-time data pooling algorithms that both flatten the data out by averaging it and decreasing the amount of data that we had to store. We also reduce the number of times that the ultrasonic sensor is checking the distance to make the amount of data we had to deal with manageable. And those corrections helped us to decrease the time it takes to analyze the data that we collected and reduced variability in our sensor data. In our physical tests, we found that the Arduino, when moved over a surface, was able to identify obstacles, shown here and here, and was also able to pick locations that were relatively flat to land, as indicated by the yellow line. As a result, we deem these tests a success, and we're hoping to move on to more advanced testing in the next module.
All right, so for this module, our design team was able to start CADing our designs that we came up with last time. So right here we have the base of our design that we're building. This with the sidebars, with it being able to clamp on to the rig, and then right here we have the parts that would attach onto C channel that are where we're going to be connecting our shock absorbers back to, with legs that are going to be extending out from here and over there. We're going to have four legs, two on each side, and then we'll have two shock absorbers attached to each of these pieces that would then transfer down. So the legs would start nice in parallel with the ground when we're starting, and then we will immediately undo a latch, which will allow them to go down and then absorb the impact when we hit the ground, which would be then transferred into this system, which we are extremely confident will have enough mechanical stress to be able to transfer the energy into mechanical stress to dampen the impact as much as possible, which we did through figuring out a lot of the physics behind it, and then looking at different materials and ensuring that we are going to have a safe landing. And then we have very soon we're going to have all of these CAD files done, and they're going to be ready for 3D printing and ready for us to start testing, which is going to be great.
The Sheehan STEM team was able to make a lot of progress toward attaining the goals that we set for ourselves and our schedule for this module. In particular, for the subsystem 1 of the landing gear, we were able to complete all of the CAD files, which turned out to be quite complicated for this module. We weren't able to complete the systems testing because we weren't able to build the system given the time frame that we had, which is why that will be pushed to the next module. On the other hand, with the sensory suite, we're able to attain our goal of designing the system and developing the software required. And upon finishing that, we were able to move forward and do successful systems testing with simulated ground, which yielded fantastic results. So we are ahead of schedule with that. As a result, looking forward, we've revised our schedule to focus more on finishing the landing gear, devising more complicated tests for our sensory suite, and developing a third system to mitigate shock when the system hits the ground. Thank you very much for listening to this presentation. We greatly enjoyed working on it.